Good morning, dear students. Today our topic is physical properties of carboxylic acid. So we will here discuss some of the physical properties of carboxylic acid, both aliphatic as well as aromatic. So first we will see the smell. What will the smell of the carboxylic acid is? So the smell of the carboxylic acid in case of lower members, the lower members of the carboxylic acids have pungent smell or they have unpleasant smell. We will see here that up to the first three members of the aliphatic carboxylic acid they have pungent smell, that is formic acid, ethanoic acid and propanoic acid. So they have pungent smell, but in next five members, that is from butanoic acid, pentanoic, hexanoic, so there is increase in the number of carbon atoms, so this smell gets faint. As a result, they have some smell, they have some unpleasant smell. Clear? But when the number of carbon atoms gets increases, there occur no smell at all. This is negligible smell occur in case of aliphatic carboxylic acids. But in case of aromatic compounds, they do not have any smell. Clear? So similarly, solubility of the carboxylic acids, but in case of lower members, the lower members of the carboxylic acids are water soluble. They are soluble in water. Solubility means whether they are soluble in water or not. So solubility in case of lower members, they are soluble in water due to the formation of this hydrogen bond. So hydrogen bond is formed between carboxylic acid and water molecule. So being we know that carboxylic acid contain the carbonyl group and hydroxyl group. So because of the polar nature of the this carboxylic group, this will be this will form the hydrogen bonding with this water molecule, because water molecule itself is polar in nature. Clear? So here we'll form the hydrogen bond. For example, there is one water molecule here. This is hydrogen 1, this is hydrogen here. So actually what happens is there this carbon carrying oxygen carrying slightly negative charge, this carry positive charge, slightly negative charge. Clear? Sorry, this will carry slightly negative charge and this hydrogen will carry slightly positive charge. Similarly with this case, there is a polarity, it carries slightly positive charge because hydrogen is less electronegative data of the oxygen. So as a result of which these two, first oxygen and second oxygen, these are attached by, they get bonded by means of this hydrogen bond. Actually there is shifting of the electron takes. We may also show shifting, pi bond gets shifted to this oxygen. As a result, there occur the formation of hydrogen bond between these oxygen atoms. Clear? So hydrogen is in bridge or acts as a bridge between these two more electronegative atoms. So here uh, we are seeing here that this oxygen atom first and oxygen atom of the water molecule, they gets bonded by means of this hydrogen. So this is called as a hydrogen bond because more electronegativity negative elements are gets bonded with less electronegative element, that's electropositive element hydrogen. Clear? So hydrogen acts as a bridge between two more electronegative atoms. So this is the formation of bond. This bond is called as a hydrogen bond. You already know about this. Clear? So due to this hydrogen bonding, lower members of the carboxylic acids are soluble in water. But while in case of higher members, the solubility of the carboxylic acid gets decreases. This decrease in the solubility of the higher members is due to the increase in the size of alkyl group. तो अल्काइल ग्रुप का जो साइज होगा वो इंक्रीज हो जाएगा, because due to the increase in the size of this alkyl group there occurs some hindrance to that of the formation of this hydrogen bond. Approaching of the water molecule to this carboxylic acid gets somehow hindered, as a result of which the solubility of the higher members of the carboxylic acids gets decreases. Clear? So we also know like dissolves like. So this is carboxylic acid is polar, this is also polar water molecule, and this is why they are soluble in water. But higher members they are less soluble. solubility gets decreased because of the increase in the size of alkyl group. Clear? But in the case of aromatic acids, the aromatic acids are insoluble in water, but they are soluble in organic solvents like benzene, alcohol, ether, etc. बेंजीन अल्कोहल एक्स्ट्रा या ईथर भी हम ले सकते हैं या एसीटोन भी ले सकते हैं. तो एक्चुअली दीज आर ईथर अल्कोहल या एसीटोन हम लेंगे ना, दीज आर ऑलमोस्ट नॉन पोलर इन कैरेक्टर, नॉन पोलर. तो एरोमेटिक acids are they get dissolved in this non-polar acids, acetone, benzene, etc. Clear? Similarly, aliphatic are also soluble in benzene, alcohol, and ether. So this is the solubility, how the solubility gradually gets decreases with the increase in the size of the aliphatic chain. But in case of aromatic, they are insoluble in water, but they are soluble in organic solvents. Similarly, here is the third point, that is the boiling point. The boiling point of the monocarboxylic acids have higher boiling point. Again, due to the formation of lower members, that is monocarboxylic acids or lower members of the carboxylic acids have higher boiling point due to the formation of hydrogen bond. So actually, there is a formation of intermolecular hydrogen bonding between the two carboxylic acid molecules. Clear? So in the above case, we had discussed how the water molecule form hydrogen bond with this carboxylic acid group. But in case of while discussing the boiling point, we will see here that lower members form the hydrogen bonding. That is the two carboxylic acid molecules. Here is one of the carboxylic acid molecule. Here is another carboxylic acid molecule. So here the hydrogen bond is formed between these two oxygen atoms. So these two oxygen atoms get attached by means of this oxygen, by means of this hydrogen, as a result of which their boiling point gets increases. So this type of boiling point is called as intermolecular hydrogen bonding. Clear? So intermolecular hydrogen bonding means hydrogen bond formed between two different molecules. So there is one molecule, this is one molecule of carboxylic acid, this is second molecule of carboxylic acid. So they get attached by means of this hydrogen bond. As a result, their boiling point gets increases. Clear? But boiling point increases with increasing size of the alkyl group. But here this is opposite rate of the solubility. Here the boiling point increases with the increase in the size of alkyl group because of increasing in the van der Waals force of attraction. Although in the solubility there is also van der Waals force of attraction, but in somehow they are soluble in water. But in case of boiling point, their boiling point gets increases with increase in size of the alkyl group. So with the increase in the size of alkyl group, we know that when the size of the alkyl group gets increases, there occurs some force. When there is no force, there is a van der Waals force. So van der Waals of force of attraction occur between the alkyl groups, due to which there is result in the there results in the increase in the boiling point of the carboxylic acids. Clear? So in short, you may remember that lower members have higher boiling point, but this boiling point, the lower members have higher boiling point due to the formation of intermolecular hydrogen bonding. But this boiling point also gets increased with the increase in this R group, because with this increase in the number of number of carbon atoms in the alkyl group, there occur a second type of interaction that's called as a van der Waals force. You had studied in the 11th class how the van der Waals force attraction occur between two molecules. So due to van der Waals force of attraction, there occur increase in the boiling point of the carboxylic acids. Clear? But here is a melting point. Melting point, it is somehow typical. You must remember there occur no regular trend. So no regular trend is followed by the carboxylic acids while they show while melting. Their melting point is different. They melt at different temperatures. Although we have seen their boiling point, their boiling point is somehow regular, but their melting point does not follow the regular trend. For example, so we have we have seen in case of carboxylic acids, we have seen acid the acid molecule with even number of carbon atoms have higher melting point. So you must remember that the carboxylic acid molecule having even number of carbon atoms, even number, that is 2, 4, 6, 8, 10, etc. So even number of carbon atoms, when there is even number of carbon atoms in the molecule, they have higher melting point as compared to that of the molecules having odd number, for example 3, 5, 7. Clear? So here we will see what the reason behind this. Actually, this is called as alternation effect. Alternation effect is the effect in which even number molecule having even number of carbon atoms have higher melting point as compared to that of the molecule having odd number of carbon atoms. Clear? So here we will see, we are see compare the melting point of some molecules of the carboxylic acids. Here we have seen, in case of this first member, there are 3 carbon atoms present. Their melting point is 251. So in case of second, there are 1, 2, 3, 4. So there are 4. Their melting point is 267. Oh, there in case of second, there are 5. There are 5 number of carbon atoms. So their melting point is 239. So this is having the odd number of carbon atoms. This is also having the odd number of carbon atoms. This is having the even number of carbon atoms. So in case of even numbered molecule, they are having higher melting point as compared to that of odd molecule, or the molecule having odd number of carbon atoms. This trend is but this trend is followed up to 10 carbon atom. Clear? We'll see here that actually what happens, what is the reason behind this. From the X-ray diffraction studies, it has revealed that acids with even number of carbon atoms have carboxylic group and terminal methyl group on the opposite side. For example, when we write the zigzag structure of the molecule, for example, we have molecule having the even number of carbon atoms. Here we have the molecule having even number of carbon atoms. For example, sorry, even number of carbon atoms, that is number of carbon atoms is even. So here is the number of carbon molecule having even number of carbon. For example, there is one is first carbon, second, third, four, and this is fifth. 4, 5. 1, 2, 3, 4, 5. Sorry, 1, 2. Yes. Sorry, actually it has been misplaced. Yeah. So actually here is there is even number. This is even number of, here is an even number of carbon atoms. This molecule is having even number of carbon atoms, and this molecule is having odd number of carbon atoms. So according to X-ray diffraction studies have seen, from the X-ray diffraction studies we have it has been revealed that the molecule in which the carboxylic acid groups and methyl groups, when they are opposite to each other, they have higher melting point as compared to that of the molecule in which the two in which methyl group and carboxylic acids are in the, they are not opposite but they are in the same, they are in the cis direction. So they are trons, we may say they are trons, they are opposite, and they are cis, they are in the same plane, they are in the opposite plane. Clear? When they are in opposite plane, they are having higher melting point, but when they are in the same plane, they are in the same side, they are having less melting point. Clear? Actually, what is happening, where the odd number of carbon atoms have those groups in the same side, actually the molecules having the even number of carbon atoms, the methyl group and carboxylic acids they are in opposite direction, as a result of which the molecule possesses some symmetry. The molecule possess symmetric, they are symmetrical as compared to that of this molecule having even number of carbon atoms. This is having even number of carbon atoms. This is symmetrical as compared to that of the molecule which is having the odd number of carbon atoms, due to which it gets fit into the crystal, and it gets fit in the crystal lattice as compared to that of the molecule which is having the odd number of carbon atoms. So it is revealed that molecules with even number of carbon atoms are more symmetrical in nature, hence fit into the crystal lattice better than a molecule with odd number of carbon atoms. So this even number of carbon atom molecule gets fit in the crystal lattice. You know what is the crystal lattice? You must have seen the closed packing. In the closed packing, we see, we know about that when the molecules are arranged in three-dimensional arrangement, there occur some lattice sites. For example, here, for example, there are 1, 2, 3, 4. That's called the lattice site. Lattice site. So here the molecule gets fit into this structure. Clear? So this side, the molecule with the even number of carbon atoms gets fitted into this crystal lattice as compared to that of the odd, as compared to the molecule having odd number of carbon atoms does not get fit into this crystal lattice. Clear? Because they are having even number of molecules, even number of molecule having even number of carbon atoms have symmetrical nature as compared to that of the molecule having odd number of carbon atoms. So this molecule gets better, this gets better, so better seated into the crystal lattice as compared to that of the molecule having odd number of carbon atoms. Clear? As a result of this molecule uh, having even number of carbon atoms have higher melting point because it gets fit into the crystal lattice. uh, Similarly, the odd number of carbon atoms, the having low symmetry as compared to that of the even membered carbon atom. So as a result of which it does not get fit into the crystal lattice, so it is having low melting point as compared to this molecule. Similarly, in case of aromatic carboxylic acids, aromatic carboxylic acids are actually planar. They are having planar structure. So in the solid state, these can be close packed in the crystal lattice. So because of the planar in nature, they in the when they are in the crystalline states or in the solid state, they get closely packed in the crystal structure. So you must have learned about the close packing in the three-dimensional, three-dimensional in the solid state. So you better know about how the molecules are gets close packed when they are occur when the molecule gets close packed, more the close packing, less is the space. So actually these aromatic carboxylic acids are planar, due to which they form close packing structures. Clear? In the crystal lattice. Hence aromatic carboxylic acids have higher melting point than even they are having higher melting point than aliphatic one. Clear? Then aliphatic. This is aliphatic carboxylic acids. Clear? So aromatic carboxylic acids have higher melting point than aliphatic carboxylic acids. So it is because of this the even number and odd number carboxylic acids, they have different melting point. It is because of the close packing of these molecules in the crystalline, when they are in the crystalline form. So when they are in crystalline form, their close packing varies. So they even numbered carbon atoms gets fit in the crystal lattice as compared to the odd number. Clear? Similarly, this this aromatic benzoic acid, for example, and these they are having a planar structure, so they form closed packet structures, and though they get fit in the crystal lattice. Because of planar nature, they get fit into the crystal lattice, so that is why they are having higher melting point as compared to that of the aliphatic carboxylic acids. So in nutshell, we will see, we can say that the more there is a close packing, more efficient is the close packing, more higher is the melting point. Clear? As you know about the amorphous and crystalline solids, amorphous have lower melting point, crystalline solids have higher melting point. It because in case of crystalline solids, they form long range order. So similar in case of these even membered carbon atoms, in case of aliphatic carbon acids, they form more efficient close packing. They have their close packing is more efficient than to that of the molecule having odd number of carbon atoms. Similarly, when we compare the aliphatic with the aromatic, the aromatic have more efficient close packing as compared to that of the aliphatic. That is why these aromatic compounds will have higher melting point as compared to that of the aliphatic carboxylic acids. So this was all about today's topic.